Hey all, this is Altbeer, and I am here to present an electronic soldering basics tutorial. This will give you all the information you need to know on how to solder. This is based on a deck that I put together a couple of years ago, but it's still pretty relevant, that you can download at solder.altbeer.us. The slide deck can be downloaded or viewed right from that website. So if you're interested in following along, that's the same deck that I'll be presenting here. So to solder, we got to figure out what is soldering. Well, it's the process where we're going to combine two or more metal items, joining them together, melting and flowing a filler material into that joint. That filler material is the solder. So basically, we're melting a specific type of metal, a specific alloy that's usually made up of tin and lead, but can be other things as well. Some of the non-leaded solder has silver in it. But this is to connect components up, electronic components that will allow us to make a circuit. So soldering equipment. Well, the first thing that you're going to need is a soldering iron. And then you're going to need some way to hold that thing off the ground and not touching anything while it's hot or while it's cooling down. And usually you'll have a sponge or some other method of cleaning the tip of the soldering iron. There is tools that you'll need. Some of the basics are wire cutters. You're going to need that to cut the different wires of the components that you're working with or wire. And I will show you real quick. If you got the hardware hacking kit that includes the soldering iron, your kit will have an iron that looks like this. And this iron has an adjustable temperature, and it looks like it's set at about 250 degrees Celsius, which is a good temp. That's about normal. I usually go a little bit less than that. I solder at about 230 degrees Celsius, but 250 is perfectly normal. Now, one thing you'll want to do if you have this iron is you're going to want to take this plastic tip off, because otherwise that's just going to melt and it's going to smell awful, and it is a discardable thing. You don't have to keep this. You can just get rid of it. One quick note while we're here, I want to show you that most soldering irons have removable, replaceable tips. This is because the tip is eventually going to wear down as you're using it. So to do that, you unscrew the base here, and most irons work in this manner, and that will take this whole piece off, and the tip is removable, and this is the part that you would replace. And they sell replacements. I think this particular kit that came with the Hardware Hacking Village kit comes with two replacement tips. All right, so, and you can also get different angles on the tips as well. That would help. As some of the other equipment that comes in that kit for the B-Sides kit, you have a solder sucker, and you have an inexpensive stand with a sponge. So it gives you a lot of basic tools, including like tweezers, wire cutters. One of the things that I included in that kit was a heat-resistant silicone mat, similar to this blue one that's here, because I find that that's easier to work with parts by laying them down on the mat to solder them than to try to get helping hands to stand it off. And but some people prefer the helping hands, and that's perfectly fine. But this is a way to protect the environment that you're soldering on, as well as allowing you to just solder right on the mat. Okay, so next slide, we're going to talk about some more equipment. So I talked about immobilization tools. These are called like helping hands. These type of tools can be used to hold a couple of pieces in place for you to solder them. the desoldering tool that I just showed you, and of course safety equipment. You should wear goggles, or in my case I have glasses that are old glasses, so I'm not worried about them getting damaged. But basically you want to protect your eyes from anything that might splatter out from the solder, because you're dealing with very hot materials, and things can pop and sizzle just like you would see anytime you're cooking anything. Some other materials are the actual solder. I find that the best type of solder to use is either a 60-40 mix of tin and lead, or they now make I think it's a 67-33, or some combination of tin and lead. I like the leaded solder because it has a lower melting point than the non-leaded solder, so it's a little easier to work with. Some people are worried about the health ramifications of working with lead, and it's a valid concern. In that case, they do make unleaded solder that uses silver, and in that case, it just has a little bit higher melting temp, so you'll have to adjust your iron. Flux is something I actually haven't used much on its own, because most of the solder that I've used is called rosin core solder, and you'll see this picture on the right shows the solder has like a hole through the middle of it that's filled with flux. That's the rosin core is a flux, so that as you're using solder, it's putting flux down, so you don't have to deal with like a big jar of it the way you would if you were working with solder that didn't have flux, because you do have to have some type of flux there to temperature regulate. That's what it's basically doing. It's regulating the temperature, it's evening out the temperature. Otherwise, you would have hot spots, and something might get burned while something else is not getting hot enough. So that's the purpose of it. Soldering materials. So the thing that you're going to solder is most likely an electronic component, and there's lots of them. There's resistors, capacitors, LEDs, you name it. You're probably going to need to solder it. And then you have printed circuit boards are the things that you would solder these components to. I have two examples of printed circuit boards here. The one on the right, you'll see, has just a bunch of holes, and whoever was soldering it, I think that might have been me, had to run wires between them to interconnect them. This type of PCB is called a peg board for obvious reasons. It looks like a peg board, and none of the holes are connected. You have to connect them. The one on the left here, you'll notice that there are copper strips connecting a lot of the different holes in various places. So this is called, aptly enough, a strip board. So the strip boards mean you can connect two components there and not have to run a wire between those holes. All right, so let's get into the basics of the soldering iron. A typical soldering iron is going to be anywhere between 20 and 60 watts. I suggest that you use one that has adjustable temperature. That way you can adjust the temp for working with different materials or different solders as you need. You're going to want to make sure that it's always in a holder that keeps that hot end, that tip end, away from things when the iron is not in your hand, because even if you turn it off or unplug it, it's going to stay hot for a while before it finally cools down enough that it's not dangerous to things. So obviously the very tip of the iron is the hottest point, but the entire metal shaft is hot enough that it will burn you if you touch it. So you want to make sure that you're only holding the part that is the cool part, the handle part, and you don't touch any of the metal parts. One other thing to note is that there are some soldering irons that look like guns. Those irons are not the best for working with electronics. Those are meant for larger solder jobs like plumbing type work. They usually are much too hot and don't work with the electronics as well because they'll burn the components. I have found some of the guns that are adjustable and you can adjust it down to where it works with electronics, but honestly it's such a bulky thing, it's hard to work with even if it's not going to burn your stuff. So just stay away from those. And then safety third, right? Safety is important. You want to make sure that you're working with something hot enough that can melt metal. You want to make sure you're not going to injure yourself working with this thing. You want to make sure that you're working in a well-ventilated area because as you're melting metal, there's going to be fumes. And those fumes can be toxic. And then, like I talked about before, safety glasses or some way to protect your eyes is important. That way something splashing up isn't going to blind you. So next we're going to talk about tinning. Tinning is the process of applying solder to the tip of a soldering iron. And why would we do this? Well, the soldering iron itself is going to look kind of rusty if you don't tin it. It's the oxides in the air and the heat at which it's operating will make it look kind of that rusty color. But worse, that rust color, those oxides being applied to the tip of the iron, reduce the soldering iron's effectiveness. It makes it to where the heat is not evenly transmitted throughout the tip of the iron. So for that reason, if nothing else, you want to make sure that you're tinning the tip. That way we have a nice even heat distribution throughout the tip of the soldering iron. So basically, if you do have an iron that's all rust looking, you want to make sure you scrape that stuff off before you apply the tin. Otherwise, applying the tin on top of that stuff isn't helping with that heat distribution. You want to remove the oxides first. And that's all this is really saying. Like I said, these slides are online, so I'm not going to read word for word the slide deck. I'm not that type of guy. So preparing component surfaces for soldering. Usually if you're dealing with a new PCB and new components, there's not much you have to do to prepare them, other than maybe like bending the legs to make sure they fit in the holes right, that type of thing. But if you're reworking something, you may have things that you have to do to prepare it. You may have to buff the pads to get some old stuff off of there and make them nice and shiny again. That way they're going to take the new solder the way you would want. And you can use something like a solvent or steel wool or even fine sandpaper will do that. So basically you just want to make sure you have nice clean surfaces for the solder to adhere to. And how do we start soldering? Well, soldering is not that difficult. It's just a process where you have to apply heat in a certain area, and then once it heats up, then you apply the solder. Now, one thing that's important to note is with a soldering iron, the sweet spot as far as heat distribution is not actually the very tip of the iron. It's just above the tip of the iron. So the very tip is going to have less heat distribution than the slightly wider area just above it. So that is the area that we really want to get touching things and making contact with things. And as far as where we're going to apply it, if you're dealing with a through-hole part, you're dealing with what's called a solder pad. That's the piece of copper that's on the PCB. And then you have the leg of the component. That's wire coming through that hole. You want to make sure that you apply the soldering iron to both the pad and the leg. You don't want to apply it to just one or the other, thinking that heat would transmit through enough to make that contact work. You really want to get both the iron to touch both the pad and the pin at the same time. That way it's nice and evenly heating both surfaces. And then you're going to apply the solder to the opposite side of that pad pin combination that the iron is on. This way it will melt in and around that. And you're going to continue heating it for a couple of seconds until you get this nice volcano-looking solder joint. So that solder joint, you want it to look like this little volcano shape. That is the best solder joint, and you want it to be nice and shiny. And then you want to let that cool off. After you remove the iron, the solder is actually going to be in a liquid state for a second or two after you remove the iron. So you want to make sure you're not jostling around the stuff that would let the solder move off of that joint, and just let it cool for a couple of seconds. So that is the perfect solder joint there. Now, if you end up with a big ball of solder, that too much solder is not going to be a good solder joint. It's not going to transmit electricity as well as this, and over time, that's going to separate from the board because it's not a nice even distribution of solder. Not enough solder, once again, it's not going to be good electrically, and it's eventually going to break loose. A cold solder joint is where you have, once again, a ball of solder that's not adhering to the pad very well. And so you're going to have poor electric connectivity, and it'll eventually remove from the board. And this situation, the cold solder joint, typically happens when you're applying the heat from the soldering iron to the pin and not the pad. If the pad's not heating up enough, you're going to end up with a cold solder joint like that. And then if you heat it too much, you're going to end up with what looks like a burnt solder joint. It may be the perfect volcano shape, but if it's all black looking, that's not going to work well electrically. And then you also want to be careful of what's called a short. A short is where you bridge the solder between two connections that you don't want to be connected, and that'll short out those connections, transmitting electricity there. So that's the basics of it. It's really not that difficult, but it takes some practice to get it to work. And here's another slide that goes into some pictures of what those different solder joints I just talked about look like. So the good solder connection, we want it to be smooth, bright, shiny, clean, and a nice concave shape. Okay? And then we already talked about all these other ones, and this solder bridge is always bad. You want to be careful of those. They're easy to do, and they can cause so many problems. So desoldering. Desoldering is simply the process of removing solder from a board to remove a component or change it out or whatever. There's several ways to do that, but basically you're just heating up that solder again with the iron and then removing the solder. Now you can use what's called a wick, which is just like a braided piece of copper that you can drag across and through the wet solder. That'll pull it off of there. Or you can use a solder sucker, which just uses like vacuum air pressure to suck in the solder into it. And this is the tool that I showed you just a little while ago. And they work really well. I think they work better than the wick method, but I know there are pros and cons to both. All right. Like I said, the best way to get good at soldering is to practice. Practice, practice, practice. So the first thing that you should do is work with a pegboard. That's that PCB that has holes that are just interconnected. And then just try placing some solder all around the solder pad and in the hole. And then once you get good at that, you can try making a bridge connection to connect two holes together. We don't need any components in it to do that, and I'm going to show you real quick how that's done. So what I have here is a pegboard. This pegboard is the same one that's included in the Hardware Hacking Village component kit. And so I'm going to get some solder. This is rosin core solder. And what I'm going to do, I'm just going to lay this down because I'm on a heat preventative mat. This thing can handle up to like 500 or 600 degrees, something like that. So I'm not worried about burning the table underneath it. And then I'm going to take my iron, and we talked about tinning the iron, so I'm going to get some solder on the iron. And then I'm going to scrape it off. Now what I'm scraping it in is this. This is one method of removing excess solder from the tip of your iron. Another method is to use the sponge. That sponge that comes with your solder stand. So yeah, let's just wipe that off. Looks like I got a little bit of sponge burnt on my iron there, but that's okay. We'll tin it again. Make sure it's doesn't have any of those oxides on there. All right, and that looks good. And so now I'm going to apply heat to the pad, but I'm not going to block the hole. I don't have a pin here, so it's easy to block the hole from solder going in it. I want solder to go in that hole. So once it heats up, I apply a little solder there. And let's take a look at that. You can see it is just a single hole, and then when I look at the back, I can see that the solder has filled up the hole. So that is a good solder joint. And the next one I'm going to do another hole. You'll notice it takes a second for it to heat up enough to melt the solder. And so now I have two of them that are filled in. And then I'm going to bridge the two by placing my iron on the PCB in between them and then melting a little bit of solder until it can bridge across, until there's enough that it will actually create a bridge. And what's funny is I always have trouble creating these bridges when I want them, but when I don't want them there, as in a short, I don't have any problem getting them to bridge. And so there, that's kind of an ugly one. I'm going to try to smooth that one out. Yeah, it's ugly, but it gets the job done. I actually got a little extra solder there. So you can see where I bridged those two holes with just a big chunk of solder. Another way that you can connect up two holes like that is by using wire. And that is the next thing that we're going to practice. So let me go back to the PowerPoint real quick. So once you get good at that, using that same pegboard, we can use wires to simulate component pins, and using those wires, we're going to solder them onto that pegboard. So let me turn off the PowerPoint, and your hardware hacking kit should have come with some pieces of wire. This is solid core wire, and what you'll want to do is just cut a small piece of it. We don't want the whole thing. Cut a small little piece off. And then we need to remove the plastic ends. So I find that if I just kind of apply a little bit of pressure while I spin the wire, it cuts the plastic around the edge, but doesn't cut the wire itself. We don't want to cut the wire, and then we can pop that off. And we're going to do that for the other side too. That way we have these two bare wire pieces that we're then going to put into the holes of the pegboard. And I'm going to bend them down a little so that we have a link like that. And we'll bend the other end as well. So we have kind of a U shape here. And we're just going to pick two holes to put them in. And actually, since I soldered this end, I'm going to apply the wire to the other side so that I'm doing all my soldering on one side of the board. It's not really necessary, but it just for this demonstration makes it easier. Okay, so I got my wire in there, and we can see the pins are sticking up through the board. And now I'm going to solder those on as if it was the legs of components. So you'll see where I'm going to hit this is right with the sweet spot of the iron touching both the pad and the pin. In this case it's a wire. And then coming on the other side. Yeah, that didn't work too well. I get it from this side. Yeah. And my board keeps moving on me, so I'm not getting a nice even temperature because it keeps sliding around. Interesting. We got some nastiness on here. I think that is from the sponge. Let us scrape that off real quick. So I'm not getting even temperature. And so one thing you'll notice when you're working with soldering irons is that the process of tinning the tip of the iron, it's an ongoing process. You're going to do it often as you work with the iron. It's not something that you do once and then you're done. You want to constantly have that tip tinned while you're working with it. Just adjust my temperature up a little bit. Okay, now let's try this. There we go. And then we'll get the other one. And you'll see that I have two solder joints there. It's kind of hard to see with this webcam. But basically, they're little volcanoes. Let me see if I can get that closer to the cam and adjust the camera to show it. So little volcanoes means they're good solder joints, and that's what you want to go for, and use as many wires to practice as you want. That way you can get to that point, because that's the goal, is just to get it to where you're able to solder kind of without thinking about the actual task of soldering. All right. We have another example that we can use as well, and that is to actually use components. So we have different components that came in your kit, and in this particular case I'm just going to use a 100 ohm resistor and an LED. Grab an LED. And we're not going to solder in a battery connector. We'll just touch the battery connector to it once we're done. Okay. All right, and so what we want to do with these components, I guess I should turn the PowerPoint off. We're going to take that resistor, and we're going to bend its legs in a U shape similar to that wire that we just did. And we will connect it between 2 points. And I just bent the resistor legs out a little bit so that it's easy to keep it in there. It's not going to fall out when you flip it over. And so we're going to solder that together. That way it's soldered to the board. Take it off for a second. All right, so we'll get this soldered up, and then we'll add the LED. Solder bent out of my way instead of applying. Okay, and so we see that that resistor is nice on there. Now, one thing that you want to do when you're working with components, these legs are going to get in your way and they could actually short out against other components. So I'm going to clip the leg, and I'm clipping it above the solder joint. You don't want to damage the solder joint by clipping into that solder that you just applied. So it's good to clip the leg, but make sure you do it above the solder joint. Okay, and next I'm going to add my LED. Now my LED has two legs. One is longer than the other. The longer leg is what's called the anode, and that's going to take the positive electrical feed, and then the cathode is the shorter leg. It's going to take the negative feed from the battery. So I'm going to put this in two holes, and you'll notice I'm putting one of those legs, the anode, next to the resistor. So my plan is to hook the positive end of the battery to the resistor and the negative end to the cathode of the LED. So we're going to solder that in real quick. Once again, my solder is bending out of my way instead of melting. There we go. Okay. Now, I could do another solder bridge the way I did with these holes to connect the LED and the resistor, but since I have this nice pin, I think the easiest way to deal with that is just to bend it over. So I'm going to wait a minute for it to cool off, because it is going to be very hot. I just melted some metal on there. And then, yep, it's cool enough. So now I'm just going to bend that wire over. So you can see that the wire that I bent over is bent on top of where I had that resistor. And so I'm going to solder now that pin to that resistor leg. That will connect them up. All right, and that looks good, but I'm going to trim off the excess wire that I didn't need. All right, and so now all I have left to do is apply some power to that, and it should work. So let's grab a battery connector. It is. All right, so what I'm going to use is a AAA battery connector, and I'm going to just put some batteries in it. And then we will touch it to the components. So we had positive here and negative there. And we see our LED lights up. So those are good solder joints. So the last thing to practice on this pegboard is a header strip, because these are used all the time, and it's something you need to get good at soldering on. So I'm putting this header strip in here, and I'm going to solder it from the same side that I've been soldering everything else. So that means I gotta put the header strip in the other way, and we'll solder these connections. And when you get good at practicing on this pegboard, you'll be ready to do some real world examples. And I'll show you that in just a moment. I'm not going to do all of these pins, but basically you can see I did a couple of the header strip pins, nice volcanoes on there. So yeah, that's something that you can practice. Once you get good with that, then we will practice putting together the header pins on the Arduino Nano and on the trinket that that we have. So let's do that. So in your hardware hacking kit, you probably got an Arduino Nano. Looks like this. Let me see. I think I have one already open. Here I do. So I'm going to give you some tips on how to solder this together. So when you put the header pins in, you'll notice that they can wobble, and we want them to be perfectly straight. Otherwise, if it's too wide, it's going to be angled out too far in. It won't connect in right. So the best way I've found to work with putting header pins on devices like that is to use a solderless breadboard. And so we're going to put the header pin in here, just kind of plug it in, and then measure out like what pin placement we're going to need for the other one. So we're going to need this one about here. And we'll plug it in. And now we will plug our Nano onto there. And you can see all the header pins are sticking up and they're ready to be soldered. And so let's go ahead and solder those. So you'll probably find that this is actually a little easier than even working with the pegboard, because the pegboard doesn't have the form that this has. It's held in place nicely for you, and all you got to do is kind of hit each one and solder it. Now, after a while, you're going to get a big chunk of solder on your tip. That's common, and you want to make sure you clear that off by hitting the sponge or whatever other thing you have to clear the solder tip with. You don't want that big clump of solder on there, because eventually it will come off, and then you'll have too much solder on a solder joint. All right, let's take a look at what we got here. So looking at these solder joints, I see I got a couple I got to redo. And that's why you want to inspect often, because this one has not melted into that volcano shape, and this one didn't have enough solder on it. And so just inspect your solder joints as you're working, and you'll have less problems and less cleanup to do later. And one thing that you'll notice when you're soldering things is that the thickness of the pins will determine how long you have to keep the iron on it to keep it hot. So if you're dealing with a really thin pin, like for a resistor, that's going to heat up really quick. But these header pins are thicker, and they take a little while longer to heat up. All right, those look good. And then, so you'll have to do this for the Arduino for your kit. And then when you are done with it, you have a nice setup Arduino that's ready to go. And then we'll do the same thing for the trinket. The trinket has only 5 pins, so it'll be fast. Let's see, get the spacing right. Yep. You'll notice I was holding the trinket down there because pressing on one end was making the other end rise up. So I've also found that when you're doing header pins for items like this, switching sides can help. That way, if you get a corner in each side, then it's not going to flip up. So once I get this corner down, then it won't flip on me anymore. And that will allow me to just do the rest of this side. When I'm done with this, I will show you the solder joints so that you can see the nice volcanoes, what that perfect solder joint looks like. And that's what you're striving to get on these, because without a good solder joint on these header pins, this board is not going to perform as well. And we are going to use these boards in the other Hardware Hacking Village events, so you want to make sure these are all in good working order. Alright, so I think that's good. Let us see if I can adjust the zoom again so we can show you these solder joints. There you go. So you see how they're nice little volcanoes? That's what you want. They're shiny volcanoes. That is the best solder joint. That's what you want to try for and what you'll practice on the pegboard to get. All right, well, that was the end of this class. Like I said, this training is all online. It is available via solder.altbeer.us. There's also a link there to other how to solder videos that other people have put together. But yeah, this soldering class was just the basics, and then the rest of the Hardware Hacking Village will use these skills as we work with the Arduino and the trinket to build circuits on circuit boards. All right, thank you so much for attending.